So, actually this, when we have a second quote, just consider the big part of it. So of course, if you that is already semi-canonical. Now we going to determine the canonical form of this periodic word. There will be many periods as many as we wish. So whatever it is. First, of course, it will be semi-canonical because we assume that nowhere in the cycle we had a forbidden word, so we had no forbidden word in the periodic word. So this is already larger than zero, semi-canonical. So we can start our procedure. The next step is certification. Certification means that we have to check what of excuse me, before it we can consider just the one layer map. One layer map will be semi-canonical, at least starting from within one period of this, because when we have a certain situation will just return in a period. Maybe here we have a problem, but inside this there is exact repetition. So this one layer map will be periodic. It's itself periodic except for the boundary effect.
You mean certified or?
No, before it. Before the usual one layer map, just taking all the possible one semi-canonical words. So is itself periodic except for a boundary because something may be here and we cannot repeat it here because it is, but it doesn't matter. So inside it is periodic. Then we go to the certification. And then we take, if we take one period inside it, then the claim is that the certification will produce the same results for the voting period. For example, if we are able to certify this site, then we will be able to certify this site that is coincides with the total period. Why? So according to the definition, how we will certify it, we have a witness for it. A witness for this will be itself some pass in this one layer map, but it satisfies certain specific conditions, we impose specific conditions on its chart, because so that what are the conditions? Here it should be less or equal than lambda 3 on this place. And let me recall that what we had, this was 1, 0. So it is lambda 0, lambda 1, lambda 2, lambda 3. So the most stringent condition, the less deviating from half. And then the next one should be less than equal lambda of rho 1. The second less than equal lambda of rho 1. The second, when we have this next, the next element of the map, less than equal lambda rho 2, less than equal lambda rho 2, etc. What is rho 1, rho 2, etc.? Rho 1, rho 1, rho 2, rho 3, etc. All of them belong to 1 and 2. So it means this should, if, for example, if we have this equal to 1, equal to 2, equal to 1, equal to 1, equal to 2, etc. So this should be is lambda 1, this lambda 2, lambda 1, etc. according to our choice of this row sequence. So we are completely, we say what is a weakness. So we are free to say what kind of condition satisfy. And now we choose the sequence that it should be A, B periodic. A, B periodic means because we consider the regularity of an angular word actually to two B periods. A and B are two B periods of the word. And that we can choose in such a way that such a word, I mean of the type, should be in a fixed number of B periods, in 5 B periods. Like in, for example, we could take an aperiodic word that it doesn't contain a proper square or proper cube, doesn't depend how you manage it. Here, it doesn't contain a 5 periods of angular word. If not enough, 10 periods, doesn't matter. Some bounded number of periods, so a fixed number. Small, say 10 periods. And then, this is what we stipulate. This could be a witness. Now, so this, assume this one side had a witness, so it is certified. Now we look the same place in other place. So we would like to find a witness for this. So, what do we say? First of all, because all of them are bigger than a half. So, and then one of the two halves might be small. It is here at less evident because we could look on this with the same, the gluing of the region with the same region. So one had to be a little more careful because if our epsilon would be small, we don't have to care about it. But here, because in the one layer map, we might have regions that the same is glued with another instance of the same. So this could be a quarter, this should be a quarter, or a quarter not, it could be in 1/8, 1/16 power of 2. So one have to be more careful, but still doesn't matter. So what I'm saying that when we take our witness, now we move this witness by a period. So because it's periodic, yes, we can move this was what witness, so we take the same. Now, then in some place it will meet the same instance of the same word, because it may be that it goes this way, or it will be the other way. Always we know that we can take the smaller part of it. The smaller part of it will be well under our context.
But you use this sequence only inside one period, right?
No, from the end to the end.
Ah.
Yeah, just because and which is a global concept, I'm looking on the whole chart of it, very, very long. No, but it just it's inequalities. Yes, if they are smaller than something, it's okay. Now, and then when we remove this distance, so if here it went, because the smaller part is always okay. It is less clear here why, because actually it could be that this is 1 to the power minus a, 1 to the power minus l, something here and something here, because there is 1. And this, because less or equal to this lambda 0, it couldn't be too big. Actually here it will give lambda 3, and this will be 1 minus this length minus to the power I minus to the power l, and minus this x cube, this length was this, minus this. So this is the length of the other side. So still we have to manipulate the constants that this should be well below lambda 3. At least one of them, but it is a question of as we calculate the constants.
Do you mean that in this competition you use relative length, not our measure that doesn't count b's?
All throughout all this argument, we use the measure that doesn't count the b's. Doesn't matter.
But then you always have one side shorter than another, or equal sides, then it is kind of flat.
No, yes, but my point is that I should know that one of the sides is securely shorter than the whole constants.
Okay.
Because we need inequalities. So what I mean, it is impossible that both of them would belong, and then we're not able to do it. But also we have to avoid the following situation, because perceivably we might have a need to go this way, then this way, then this way, then it may be longer than expected because two sides may be included in it. So one has to care that it doesn't happen, because actually in the situation we know that we have a kind of a safe haven going only by this side. And as far as we've reached the safe haven, we don't need to care anymore. Then we just flow with this safe haven up to the end. Because the problem is how to reach the safe haven. Now, and then when we are here, because now when we come to the next one, so one of the sides is the safe haven. If we have reached it, go. If we haven't reached it, so we have this side. Now, but this side is bounded by lambda 3. Because I say, in the period, lambda 3 is significantly smaller than all this, lambda 2 and lambda 1. Then we just here, reaching this, we are, the constants are chosen in such a way that if this is less than we can go here and we reach the safe haven. Because here, the worst thing that could happen, that is 1/8, right?
Yes.
So, which have to take this, that what is the distance between is 1/8. So then, I mean that whatever it is, because it's less than lambda 3, this plus 1/8 would be less than lambda 2. So we are able to that at this place, our witness is switching the chain, the sides, because of the choice of the constants. And then it goes further with the safe haven, just a smaller side. Now, if 1/8 is too big, then 1/8 consider the situation that we took together 1/8, and then we switch with 1/16. Maybe if our constant is not good enough for 1/8, then we can take this in one conglomerate, all these that have the content of 1/8 until we have 1/16 and we go with it. But I think it is the problem even this. So what goes on? So it means that from a witness from this, we're able to have a witness from this. It means that the certified one-layer map is itself periodic except to 2 or 3 periods from the ends for the same reason. Because we're able to move a witness from one to the other, and then we need to take a surgery of the witness, take it to the better side, and then okay. So this means that then, when we go to the next step, to the certified side is in itself periodic, except for the ends. Then, because the competition in the next step is local, we just look on the 2 neighbors of 2 sides, because the certified map is periodic, so we move a period, we have the same neighbors, so actually it will be the same competition and the same outcome, except for the boundary. Now we have to count 3 or 4 periods from the boundary on one side, 3 or 4 from the boundary. It doesn't matter because we, from the beginning, could take it as long as we wish. The power of W is not bounded. It's a matter of our choice. Then what happens is then the result canonical map would be periodic. Either it is a periodic just because we have only one choice. If we had this situation where it is undecided, then this situation being undecided will also appear periodically. In the same way. And then the next thing that we have to do is to fix the values of the parameters. Again, it is a local problem. We consider each time the same local situation, and we have the same decisions. Again, just taking one more period from the ends. The final outcome of it is that we have the canonical form becomes periodic. And then, being periodic, we take it the one period, and then we have the canonical form of second quote. But it itself is periodic up to ends. We don't count the ends. This is the way how we deal with the second quotes. Taking big periodic powers and then going through all the steps of defining the canonic form, and then the outcome is periodic. This period will be the canonical form of the second quote. Okay. Now, before we can do, no, we need the canonical form of a pretzel. Why? Because, as we have told, the angular relation is a, so this is A, this is B, and this is B. The angular relation is a covering of a pretzel. Is because we go the power A, then we take B, this sign of the other sign, then we return with the opposite sign of A, we take B this way or this way according to the sign, so we continue. Now, when we reach the situation when there is a big power of b, for example, when we have here b to the power alpha, then we just have the big number of here. We just take a big power of b on the side and they continue. So in any case, even we know that inside the form of the Bernoulli relation we took here, there are depending parametric value of b. Anyway, we can read it from the covering of the pretzel. But then maybe we needed to do many times just going through this and then we go. Now, each of these b's we can replace it by the cyclic canonical form. So we can assume already that this b is canonical on both sides. But then we have some indefinitely big power of b, canonical of b. Already assumed canonical now. Here we have also indefinitely big power of this. And then we have some a. So a itself may be assumed canonical, why not? But here, when we take it this way, for example, we should go this way, taking this, returning, this is A, this is B, this is A, then going, for example, this way. Now this way, it segments are canonical, but it need not be canonical itself. Because we need actually the canonical word corresponding to this word, not this segment itself. So what we need now to consider is the canonical triangle of words. So if we have two words and their product, and then we take the canonical word, then we have to understand how the canonical triangle looks like. So again, we can do it on the level first of the one-layer map when we forget of the powers of B, and then choosing the powers of A. So then when we take it, the canonical triangle, so first on the level of one-layer maps, so how it happened, we're told that actually originally we had a thin triangle. Instead of one-layer map, we have a thin triangle. Whatever it means. Now, because I mean that all the possibilities to have a semi-canonical word for this one, and for this one, and for this one are contained in the thin triangle. Because I mean, gluing one layer map, the other and the third together will be a thin triangle. Now, but now we have to choose the canonical form for this word, and for that word, using the same steps. So first we have to have a pass, a single pass of this form that we have got over trained. So what actually we obtain after taking the canonical form? The single pass we have after this inside the triangle. For this one, we have a certain path. Certain types, part of it could be this kind of train, it's continuous, etc. And the same kind of the structure on the other. So here is a certain single path maybe, then a train, then a second, etc. So, and this is the first step. And the same procedure for this one layer map and the same procedure of, so in a same triangle, we have three one layer maps. I mean, this one, and this one. And now we're asking whether the choice of the passes will agree or disagree when we perform it for each one layer map apart. The question is to which extent the choices we make in these three one layer map agree or disagree. This is a question of calculating the first step in determining the canonical form. So the question is, how could it happen a disagreement? Because the disagreement, I mean, on the first in the certification. The question is, how could we have a disagreement on the step of certification? This is the first question. How actually is emergency, disagreement in the certification step. How can a disagreement occur during the certification step? Okay, that means that certain side here is certified when we consider this one layer map, but it is not certified when we consider this last layer. So it is certified for this side, it is not certified for this. We have two different maps, and if it would be agreement, yes, then the outcome, the next step will be also the same, because the next outcome is local. It doesn't involve parts of the chart which is distant from this. But here it is global. The process of certification is a global process. Okay, it means that for this one, we do have a witness, and for this one, there is no witness. We cannot certify because we cannot find a witness for it. But here is an argument. Why cannot find a witness? If going along this witness, and if at certain place we're able to switch side to the safe haven, then we construct a witness. This is what. So if we are able to switch sides to the safe haven, we obtain a witness for the other one layer map. See this. Now, so it means that all our efforts to switch sides are unsuccessful. Otherwise, it will be certified in this also. So, we are unable to switch sides. What happens? So we go here. So the first attempt should be at the spot. So this is less or equal than lambda 3, right? Because we know that this is a witness. If we could switch the side and remain without the same, then we just continue to safe haven in better. So we cannot. It means that this one together is bigger than lambda 3. So we are forced to continue here. Now there is the next attempt. Again, we cannot. So this one will be bigger than lambda rho of 1. Then the next, etc. So it means that all of them are unfortunately bigger that we cannot switch side. But it means until we go to the middle of it, all of them are bigger than the constants that are predicted by that stipulate the construction of the witness. On the other side, themselves are less or equal to lambda rho 1. Otherwise, this itself would not be a witness. This is a witness. Here we can, here we can. So it means that always this is in this interval. Now, if we would have only epsilon, the situation would be simple. A very small number, so this will be very strong prescription on the legs. It could be here. It would be less than lambda rho I, but bigger than lambda I minus epsilon. But it will be smaller than epsilon, then we can just add this and we are done. But here we have not only epsilon, but also it may be a contact between the power 1 or the power of 2 of the links. This is also possible. Now, in any case, all our efforts provide nothing, and we have to go this way. So there's no witness. So then what happens? That this discrepancy between the certified one layer maps with the two triangle, two one layer maps. This one does contain it, this one doesn't contain it. When we have a discrepancy in the certified map, then there may be a discrepancy in the final outcome. Because after we have the certified map, now we proceed to the final step of choosing the sides. And then we choose sides lexicographically. By the way, the graphical we even can count the bees, doesn't matter. Anyways, so it all remain, it would remain with the equal sides also. In any case, what happens here, then when we, what happens here, because all of these are bigger than 1/2, then their complement is smaller than 1/2. So I mean, until this what we call the domino area, including this, the final choose of size will be different, because this was big enough and this is small enough. But now the next one, then when we take the competition for it, it could happen then when we had this edge in the certified, then we were able to make it shorter because we didn't go this way. And maybe then it won the competition. But when we did not have the certified, then we only have to go this one, and then this one wins in the final outcome. So it means that if we have a change in the step of certification, so nearby we have a change in the step of the final outcome. By the way, here, in the previous situation, there was just only one. The next one the same. Here it could be that we have arrived at a symmetric. Maybe all of them are here in a symmetric situation, just a train. Very long, but possible. Even maybe even until then, that's matter somehow. So and then when we had this part certified, then we actually had a train. When we didn't have it, so the symmetry was done. So we may have now we have only to choose this side of the train. So what I mean that previously the influence of this will be only on the next area, and the choice of every other will be just the same. This was in previous hyperbolic case. Here, because of the possibility of such a full symmetry, it could go as long as we wish. But actually, in a very specific situation, that all this is actually a one composite flat. And with one composite set, then we have to decide what kind of choice of parameters we have to do. Maybe that it ends and then we have the same situation. Maybe it goes at the end. We don't know. It doesn't matter. In any case, this is what happens. What could be the difference of the outcome for the two binariums? Here it just chooses this one. Here it may choose one section, and then it will be full this section. And then also, then the next one will also be changed. But this is because this have an addition choice. But the rest, no, doesn't matter. Because here it is no, then, excuse me, no. Because the certification is the same. Because this is have same path certification. So the next will be the same. If it is this was symmetric, if here the symmetry will lost, then it will be the same, because we decide not on what happens now, but on the certified part. Certified is the same. Certified was the same, the decision was the same. Now, here the decision will be on this side, because the numbers are bigger than 1/2, so in the final competition, all of them lose the too long. And then we have this one. Now, so this is the domino area. Now, what is very important part of it? that the dominant area must be in a fixed number of B periods due to the choice of the sequence is very important. The dominant area. So if this word would be a part of some angular relator, then the dominant area must have a fixed number of B periods. As if the word is a part of some big angular relator, the dominant area lies in a fixed bounded number of its B periods. B periods. In the B periods, in a relator AB, we call A and B as a B periods. I have to explain it why. What I will do it next time. Because it's not immediate. Because actually, if it will be just epsilons, let's be clear. Because what we have on the other side is 1 minus the length minus 2 epsilon. And because these are different, then from the difference of this, we learn which kinds of alpha have lambda 2 or lambda 1. But here we have also the halves, or the powers is the power of 2. But then because of the structure, or combinatorial structure of the angular relator, we are able to establish, I have to prove it, establish what kind of lambdas we have on the other side. And then, because we have this arbitrary periodicity, it will still be in a fixed number of B periods.